Welcome to another Check on Learning. Do you like how I'm out in space? Alright, let's get started. So, this is our Check on Learning for section, what is this, 3.2. Yeah, 3.2, Analyzing Graphs. So, let's get. Alright, so this is our first one. Directions use the information to answer parts A and B. Is it possible for a point on the graph of a polynomial function to represent a turning point, local maximum, and a zero? Use a graph to justify your answer. So I'm just going to sketch this out real quick. So we've got our graph, and they're saying, is it possible for the point on a graph of a polynomial function to represent a turning point, a local maximum, and a zero? So a turning point is just anywhere where the graph turns, and then assuming this were a zero right here, then I think we should be good to go. So I would call this a local maxima. I would call it a zero because it's crossing the x-axis, and I would call it a turning point. So I'm going to say yes. So let's see what we got. It is possible for a point on the graph of a polynomial function to represent a turning point, a local maximum, and a zero. Okay. Part B, which of the following graph correctly justifies your answer for part A? So first one, no. We'll put them all on the screen. So no, 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 because there are no local maximums. Oh no, I take that back. Are they looking for local? A local maximum. Okay, I take that back. Let's clear this out. So we're looking for local maximums that are at zeros. So actually, if you look at this guy, that's a local maximum. It's at a zero, and it's a turning point. Let's look at the other ones just in case. We have a local maximum there, but it's not on our x. Local maximum there, again, not on our x-axis. These are both minimums, so I don't even need to worry about that. So I'm kind of going with that one. See if there's any other options. Nope, that's it. So that's what I'd call that one. So use a graphing calculator to graph the polynomial function. Determine the x-intercept, whether the graph crosses or is tangent to the x-axis at the x-intercept, the number of turning points, and the number and type, global or local, not global, or any maximum or minimum values. Now that's a lot, but so I'm just going to copy this and see if my handy dandy website here. Ha, money. So this is just a graphing website that I found. Oh, move me out of the way. So we're going to zoom in so we can kind of see what's going on here. So there's our graph. Notice we've got one right here that crosses, another right here that crosses, and then a third that crosses. We have a local maximum right here, a local minimum right here. So maybe I can label that better. So crosses, 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 local maximum, local minimum. So now we just need to find the graph that kind of looks like that, right? So max right above 2. So remember, our first local maximum was right above 2. So I think this is the one that we're looking for. Okay, determine the x-intercepts of the polynomial function and enter the correct number in the boxes below. So we've got an x-intercept at -2. We've got one at 0. And then we've got one at 1. So again, I'm just looking at where the graph crosses the x-axis. We could also check these answers up here. So we're just going to write this down. X minus 1, x plus 2. So our x-intercepts, -2 right there, 1, 0, too easy. Part C, determine whether the graph crosses or is tangent at the x-axis at the x-intercepts. So we'll do it one by one. So from left to right, the first x-intercept of the graph crosses, that's that guy right there, the x-axis, and then at the second intercept, the graph crosses, all of these cross, if you haven't noticed this yet. So it crosses, crosses, and crosses. There are no tangents to the x-axis in this example. How many turning points are there in the graph? So let's go back up. We've got a turning point here and a turning point here. So remember, turning point is anywhere where the graph either goes from increasing to decreasing or decreasing to increasing, otherwise known as anytime it changes directions. So there's 2. What is the number and type of any maximum and minimums? So because it is an odd function, and I know that because it's coming down this way and coming up that way, there are no global maximum and minimums, but we have one local maximum and we have one local minimum. Maximum, minimum. We have one, that's not right. We have one local maximum and one local minimum. Cool. So let's see, you're using a graphing calculator to graph a polynomial function, determine the x-intercepts, whether the graph crosses or is tangent, and blah, 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 blah. This is the same as our last problem, but I'm going to assume that this is a slightly different graph. Probably has some tangents. I don't know. I'm just guessing. So again, at this point, you would stick all this stuff into your graphing calculator, or if you want to use this website, whatever. Yeah, look at that. That's crazy. So worth noting, we have a local max and a local minimum. We're going to zoom in. Our local max is at what? 10. So each one of these boxes is 2. Oh, look, it tells me. So 22, 24, so slightly above 24. And then we've got it crosses, it crosses. Ooh, this is the wrong graph. Look at this, I didn't copy it correctly. I knew there was going to be something wrong here. To the power of 2. There we go. Didn't make sense for there not to be a tangent here. So here we have a tangent, and we, at this point, do have a local maximum. So, back up. We have a global maximum, a local maximum, a local minimum. And there's the bell. So, okay. Oh, they have weird scales. So I'm going to go with this one. Looks the closest to there. Again, there's scales here, just a little bit different. That's why it looks a bit different, but still the same graph. Determine x-intercepts of the polynomial function. So there is one at, so if I'm just looking at this graph, there's one there, there, and there. So what is that? -5, -1, and 2. I can check that by looking at my equation up here. X plus 5, x plus 1 squared, x minus 2. So all these numbers fit in. So right here, x equals -5, -1, and x. If I'm trying to find my zeros, oops, not x, 2. Determine whether the graph crosses or is tangent at x-intercepts. So from left to right, we've got a cross, a tangent, a cross. Remember, cross is when it goes from one side of the x-axis to the other one. A tangent is where it just touches the x-axis. So I'm trying to write a tangent in front of that one so that I remember from left to right. It crosses is tangent to crosses. How many turning points are there in the graph? So again, when we go from increasing to decreasing or the other way around, so we change directions here, change directions here, and here. Get rid of all of this stuff. So what is that? 3? 3. Let's do 3. Here we go. 3. What is the number and type of any maximums or minimums? This is where it gets fun a little bit different than what we've had. So we've got, we'll go with red. So we've got a global maximum, a local minimum, and a local maximum. Again, this one is local here because these points are in fact above them. And then there are no other points that are above here, which is why it is a global maximum. Cool. So let's throw those into our answers here. We've got 2 local maximums. That's wrong. 1 global maximum. That's wrong. Wait, what? 1 global maximum. 1 global maximum. 1 local minimum. 1 local minimum. Not global seems weird to add in there, but whatever. So which of the following is the correct graph of this? So step 1, I'm going to figure out what our intervals are. And I can already tell you that we've got 0, we've got 2, we've got -3. So those are our x-intercepts, so we can immediately eliminate, let's look at our options here. Let's see if we can eliminate enough of them. We can eliminate this guy. We can eliminate this guy because it's got a -2. We don't have that. So this one has a -3, 0, and 2. This one has a -2, which is not right. So we'll go with this guy. Boop. So again, I just found the zeros, matched them up. Oh my gosh, it's lunchtime. Just kidding. Last but not least, Ricardo is creating an open top box. This should sound familiar. From a piece of cardboard, he forms a square and the flaps side length X at each corner by making a single cut. Blah blah blah. He then folds the four sides of the box, glues the flaps together. What X to the nearest tenth maximizes the box's volume? So we did this one in one of our tasks that we did. So first step, what is our volume equation, since that's what we're going to try to maximize. And for a box, our volume equals length times width times height. So then in this situation, our length is that value right there, which is going to be 20 minus 2 x's. So length equals 20 minus 2x. Our width, we'll switch to blue and be fancy, is this part right here, which is equal to 15, which is the total length, minus 2x. And again, that's because we have an x there and an x there. So 15 minus 2x. And I'm just putting parentheses around it because that's what we're going to do later on. And our height is going to be our x, right? So h equals x. So then our volume turns into 20 minus 2x, which we could factor that if we wanted to, but I don't really want to. We don't have to. And x. So I just plug these values into here. So in calculus, you will learn how to find the maximum with this by using math. We are not in calculus, so we are going to use a graphing calculator. So we'll come over here, and we're just going to enter this in. 20 minus 2x. I love this program because as I enter it in, it shows me how the graph is changing, which I just think is kind of cool. 2x and then x. So since we're dealing in the physical world, all of this stuff down here below the x-axis is meaningless to us because you can't have a negative length. That would be weird. Let's zoom in. And let's see here. What number are we at here? So that's 7.5. This one is 10. And what was our dimensions? I think we can get rid of that one. So if x is greater than 15, that would not be helpful, right? Because if x was greater than 15, then that would be 0. And again, that would be non-existent. So if we go back here, so that's 10. I'm assuming that that's probably not our answer because that's the one that goes up forever. So that means that this hump is the one that we are really looking at. So here is, come on, whew, that is crazy. So I'm just going to write that on the screen so that I don't forget it. 2.8379. So that's our xy coordinate. So what do those numbers mean? That means if we make x 2.8, our volume is going to be 379, which is a maximum for what we're talking about here. So we go back here, enter the correct value. As I mentioned, 2.8 centimeters is our x, and then this is going to be our volume. So we would just type in 2.8. And now you guys are ready to learn calculus. I'm just kidding. You have at least a semester or two before then. So there we are. That's our check on learning. And as always, I will see you in class. Bye.